All right, welcome everyone. Once again, I want to say a very big welcome to each and every one of you, wherever you're watching from. Good morning, good afternoon, good evening. Okay, today I just want to show you how to wind a low frequency transformer. In my last video, I taught how you wind high frequency transformer for switch mode power supplies, but this one is a low frequency transformer. They have other methods, another way of winding it. This is quite easier because it's low frequency. For high frequency, we have you know um, more complicated calculations. So I'll try to keep it as short as possible. Okay, if I'm to wind this, okay, if I'm to wind this transformer, the first thing I'm asking myself is how many turns do I need to do for the primary for a particular voltage I want to achieve? How many turns for secondary? Okay, but for this particular transformer, I'm going to be winding 70 volt on one side and around 18 volt on the other side. So we're going to just quickly do the calculation, but the same principle applies to winding 220, whatever voltage you want to achieve. Just follow the same process, you get it. All right, so let's um dive right in. The first thing you do is calculate the core area, and like I explained earlier in my previous video, your core is the area around which you're doing your winding. So if I'm winding around this area, then this is my core. So we want to calculate for the core area. I'll measure my, what's this, length or breadth, whatever. Okay, breadth. 5.12, let's say 5.2, length, breadth. My breadth is 5.2 centimeter. Then the length is around 13. By the way, I made this bobbin. If you need to learn how to make this, you can drop it in the comment section. I'll take out time to teach it. All right, so this is 13.2. The length is 13.2 cm. And remember, I said I want to achieve 18 volt on one side and on the other side 70 volt. All right, so the first thing I do is I'll multiply these two. 13.2 times 5.2 gives me 68.64 centimeter square. So these are core area. All right, core area is this. Now the next thing to do is use a constant 42. I'm going to divide this. I'm going to divide this with 42, so I'm going to have 68.64 as the denominator. Let's see what this gives. Now whatever this gives is your what we call turns per volt. Turns per volt. For those wondering what the spelling of bobbin is, bobbin. All right, okay, so that's by the way. So what we're calculating for here now is turns per volt. How many turns do we do for every 1 volt we want to achieve? All right, so 42 divided by this, 42 divided by 68.64 would give me 0.611, let's say 6119 turns per volt. All right, now the next thing we want to do, it makes it very simple. For 18 volts, we do what? 18 times 0.6119. For 70 volts, we do 70 times 0.6119. Let's see that what that gives. 18 times 0.6119 will give me, I'll take it to the nearest whole number. This will give me 11 tons. All right, and then the other one would be 70 times 0.6119 gives me 42, let's say 43 tons to the nearest whole number. So that's it. If I wind this 11 times around this core, it's going to give me 18 volts. And if I wind around this core 43 times, I'm going to get 70 volts. All right, so that's just it about transformer low frequency transformer winding. Maybe when I'm done, I'm just going to show you how it looks at the end of the day. But this is just what you need for any voltage you want to wind. It works. Thank you so very much, and do well to subscribe to encourage us to continue to do content like this. Thank you once again, and see you later.